You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. David Pooley. David Pooley received his PhD in physics from MIT and teaches at Trinity University. His research focuses on extreme and energetic astrophysical phenomena, studied primarily with the most energetic forms of light, X-rays and gamma rays, and works on the reduction and analysis of data from NASA's premier satellites, including the Chandra X-ray Observatory.
Dr. David Pooley, welcome to the program.
Thank you for having me.
Now, Doctor, X-ray astronomy is hard, and it's hard. It's it's hard for several reasons. One is that the Earth's atmosphere, at least at the surface, is opaque to X-rays. You just can't do much with it. Secondly, they're very hard to focus because it's not really very interactive with materials. So having the capability to do X-ray astronomy is something very cutting edge, very recent, other than balloons and things like that were being done decades ago. And we have that capability in an instrument known as Chandra. And Chandra has, it's thought, and it's been going for many years now, but it's thought to have plenty of life left in it, but it's under threat. Can you give us an overview of the situation with the Chandra telescope?
Oh, absolutely. I'd be happy to tell you what's going on currently, and if there's any of the history of X-ray astronomy and making of Chandra that you'd like me to talk about, I'm happy to do that as well. What's happening right now is actually twofold. There are two things that happened recently that are threatening X-ray astronomy in the United States. The first one was a result of the 2% across the board budget cuts from last year. And the way this got filtered down into NASA astrophysics was that almost all of that reduction was coming from Chandra. It wasn't being split evenly, it was coming mostly from Chandra. And that had the effect this year of reducing the amount of funding going to scientists, postdocs, grad students working on Chandra data that are currently being taken. So this is very dangerous because the way the process works is last summer, at the end of last summer, we were informed whether or not our peer-reviewed proposals were accepted. And the oversubscription for Chandra is high. It's, 1 out of every 6 proposals might get accepted. And if you get your proposal accepted, then there is money available to fund the time, to do the analysis, to publish the results, to present them at conferences. This is how science works. And so we were given a number at the end of the summer. This is how much money could be available, and come up with a budget and see if this meets your needs. And so we did that, and budgets were approved. And then when observations started to be taken, which was roughly around the calendar year start, the money was not coming because there were these issues with the continuing resolutions in Congress and whether money would be available. And then well into the yearly cycle of observations, all of the researchers, scientists who had approved observations, that had approved budgets, were told, your budgets are being reduced by 30%. The funds are being reduced by 30%. So you now have to resubmit a budget and try to do the same amount of work for 30% less money. And that, as I said, is dangerous because these groups rely on that money to fund postdocs, to fund graduate students, to send them to conferences to help further their careers. And now all of a sudden, a good chunk of that money went away. That was, approved as what was necessary to do the work. And when that happened, myself and others on the Chandra Users Committee, just a group of scientists who helps to serve as a conduit for the community to the Chandra X-ray Center, we drafted an open letter meant to be delivered to NASA Astrophysics as well as the Science Mission Directorate Associate Administrator, so about as high as we can get in NASA. And on, I believe it was a Wednesday or Thursday, we opened it up and we sent it to a few lists of X-ray astronomers and other astronomers. And by the next Tuesday, so a few business days and a weekend, we'd gotten over 700 signatures on this open letter, including a Nobel laureate, including a past chairman of the Decadal Survey of Astronomy and Astrophysics. Many, many influential and well-respected people in the field signed this letter. And this was because of this reduction to the funding available and the disastrous effects that it would have. Now, while this was going on, and we were addressing these cuts to the current year funding, the president's budget request for the next couple fiscal years came out. So this is for 2025 and 2026. And the way that budgets work is a bit confusing, and most people aren't familiar with it. I wasn't very familiar with it until I had to be. But what happens is the president, the executive, forms a budget request and gets submitted to Congress. And that is the sort of starting point for the process. And we don't have a budget until Congress approves it, usually sometime later on in the year in the summer. But until that is approved, what has to happen is all of the federal agencies have to plan according to the president's budget request, because that's the only guidance that they have. And they have to have plans for the future. And in this president's budget request, in the NASA portion of it, the funding for Chandra was going to be reduced from 70 million to 41 million in fiscal year 2025. And then in the next fiscal year, another significant amount down to 26 million. And cuts of that magnitude are not just going to make it hard to further the careers of future students and postdocs, they'll make it impossible. It's going to cause a death spiral in the field of X-ray astronomy.
And it's worth noting that $70 million to the United States government is nothing.
It's pennies. It's absolutely pennies, fractions of a penny.
Now, say you could get action in Congress going on this one, and we'll get into how that can be done and how the audience can help in a minute. But once you get the attention of Congress on this, what can they do to restore funding specifically to Chandra?
They can give it a line item in the budget. This is, and again, for people not familiar with how budgets work, the way that this actually happens for federal agencies, when Congress passes a budget, they might say, okay, we are going to give your agency, your department, this amount of money. But we're also going to mandate that you have to spend a certain amount on A and a certain amount on B and a certain amount on C. And then whatever is left, then you can fund all the other things that you have to do. Now, that is a problem for Chandra, because Chandra is not one of those things that has that line item that says you have to spend this amount of money on it. And this is in great contrast to the other of the still flying great observatories, which is Hubble. The Hubble Space Telescope has always had a line item in the congressional budget. The James Webb Space Telescope has a line item in the congressional budget, but Chandra does not. And that's what makes it vulnerable. And if we could just make that simple change to restore its funding back up to the 70 million that it needs with a line item in the congressional budget, that way NASA can't, when it has to cut things, it can't touch Chandra. And it shouldn't, because it's our flagship.
Now, the first thing that we need to note here is that Chandra is the premier instrument for X-ray astronomy, number one. Number two, it has life left in it. As much as a decade left as far as fuel goes.
It does.
So we've already paid for this instrument.
Yes.
And why would you shut it down prematurely and not get your money's worth out of it as much as you could? So what is the health of the spacecraft like? How is it holding up?
Chandra is holding up incredibly well for a 25-year-old instrument that has been in space subject to that environment. It is a harsh environment. Chandra has gotten a little bit more challenging to operate, to plan the observations and make sure that the satellite is doing so in a safe and healthy manner. But the people who are doing that at the Chandra X-ray Center are so amazing. They are so incredibly skilled at coming up with creative solutions to the challenges that naturally arise as a satellite operates, that they have been able to mitigate anything that's come up. They have this wonderful long-term plan for how to handle future events if they should arise. So there's a plan in place, and it doesn't require any more people to operate. It's not like Chandra needs more money, it just needs the same amount that it has. I mean, over the course of the mission, the staff needed to operate the mission has actually reduced because they've gotten so efficient at the mission planning. But right now they're at the bare bones minimum. This is how many people it takes to operate the satellite. And so once you cut that in half or more, I mean, those people leave, you can't operate the satellite anymore, and you can't fund scientists to actually analyze the results and publish and spread that information around.
And that in turn, with no funding, means no one else is going into X-ray astronomy.
Yeah, exactly. I mean, what do you need for a vibrant field of research, right? You need the facilities, you need the tools, and you need the people to actually do it, right? These budget cuts are going to make both of those things go away.
And there's also the question of keeping the U.S. preeminent in scientific research. $70 million isn't much to keep X-ray astronomy going.
I know, and this is a Nobel Prize winning field that was born in the United States. This was a field that we pioneered. We made the most amazing discoveries. We built this amazing facility, Chandra, that has the sharpest X-ray vision that has ever flown and that will ever fly for at least a decade. There's going to be nothing coming close to Chandra, nothing in the pipeline that will have the resolution for at least another decade.
But if you keep Chandra going for another decade, because that's the long estimate on its fuel, then you bridge the gap or get close to it anyway.
Exactly. It seems like a no-brainer. And that's why this president's budget request just completely shocked everybody. There's going to be nothing to sustain the X-ray community through this. And this isn't something that you can just flip a switch on. You can't just turn off the lights and save electricity for 10 years and flip that switch and expect X-ray astronomy to just come back on. That's not how it works.
Now, how did we get to here in the history of X-ray astronomy? Can you give us an overview of just the development and the challenges that were inherent in even being able to study X-ray astronomy? As I recall, it was originally just a prediction that the sun would be producing these things, but we had no way to even observe it down here on the ground, right?
Exactly. And I mean, lucky for living organisms, our atmosphere does block X-rays and high energy radiation, but it does make it hard if you want to view the cosmos in those wavelengths. And so the earliest observations with balloons and sounding rockets detected X-rays from the sun. And so there was a clear source of X-rays out there. And naturally, the same as Galileo, once you open up this new window with a new telescope, you want to see what else is out there. And so the instruments got more sensitive. Clever ways were devised to get some sense of where the X-rays were coming from in the sky. And as more development happened and more sources were discovered, we realized very quickly that the X-ray sky is very different than the optical sky. When you go out at night and you look at the night sky, it's pretty much the same night to night, right? The stars are not doing crazy things in optical light. But X-ray sources are completely opposite. If nothing else, the X-ray sky is variable and violent and exciting. Sources come on and off out of nowhere. Some that were bright for a decade suddenly turn off. And all kinds of phenomena happen that people had to understand. And this is what led us to discover and prove that black holes existed in a binary system. And that there were these amazing things called, neutron stars that had these X-ray bursts. And it was extremely exciting. And so, of course, with all of these interesting things out there, you want better and better understanding of exactly where they are, what they look like, what their spectrum is. And so the process was started soon after the field was born. I forget exactly when the first AXAF, Advanced X-ray Astrophysics Facility, that's what Chandra was called before it was Chandra, when that first proposal was, but I want to say it was in the 60s or 70s. And so there was a long-term planning here. And as you said, it's incredibly hard to even make an image in X-rays because those photons are so energetic. If you tried to reflect them, like with mirrors and how we do with optical light, the X-rays would just go right through. And so it's a really difficult thing to get those X-rays to come together and form an image. And it's not unlike skipping a stone off the surface of a pond, right? If you drop that stone straight down, it just goes right through the surface. And that's what would happen with a normal mirror and X-rays. But if you throw that stone mostly along the surface and you just skim the surface, it can actually hop and hop before it might finally plunge in. And that's basically how the X-rays are focused with Chandra's mirrors. So it was an incredible amount of technological advancement and engineering that went into making Chandra.
All the more reason to keep it and use it to its fullest extent until it runs out of fuel.
Absolutely.
Now, with X-ray astronomy, though, and let me ask you this. What are the unsolved mysteries that lie within X-ray astronomy? This is an entire chunk of the electromagnetic spectrum that we might be able to, well, we're in danger of losing the ability to study as well as we can right now with Chandra. What are some of the outstanding mysteries that we could use Chandra to continue to probe?
Well, there are so many. So, I mean, my list is going to be a little bit biased based on what I'm interested in, but there are a number of fields that we will only get definitive answers on them with sensitive instruments like Chandra, with the high spatial resolution, with the energy resolution like that. So some of these are in understanding the formation and growth of supermassive black holes across cosmic time. I mean, we see all of these supermassive black holes today. We see them earlier and earlier in the universe. Some of the most exciting results from Chandra have come just this past year with the combined observations with JWST and seeing these supermassive black holes in the very early universe associated with these very early JWST detected galaxies. And how you build those black holes, how you get them so massive, and how they grow over time. And is it just one way, or do they have multiple channels? These are some of the biggest questions in black hole research. But there's other things as well involving black holes, but more broadly to a process that we see over and over again throughout the universe, which is the material falling onto something like a black hole or a neutron star or even a normal star, right? We call it accretion. And that matter, it forms an accretion disk. And how these accretion disks work is still a bit of a mystery. There's physics inside of them that we don't fully understand and that we get insight into by studying certain things in X-rays, studying neutron stars and black holes with these accretion disks in these extreme scenarios. A lot of the work that I do deals with trying to understand just how big these accretion disks are around supermassive black holes, because they're so physically tiny and these things are so far away. We can't directly resolve the accretion disk to measure its size, but we have some really clever indirect ways to measure its size that are only able to be done with something like Chandra.
And the accretion disk of a black hole is probably the most extreme environment, or one of the most extreme environments anyway that you're going to see in the universe. And just imagining one is terrifying.
Yeah.
Now, working in conjunction with JWST and Hubble with Chandra, these are three different areas of the electromagnetic spectrum. Hubble obviously is visible light, JWST is infrared, and Chandra is X-ray. This gives you three different perspectives of the same astronomical objects, looking at a galaxy or supernova remnant or something like that. And you can just get this wide collection of data from these specialized telescopes, and it just would be a shame to lose that capability in X-ray. What about, now, with these telescopes working in conjunction, what about transient events? Like say a supernova kicks off in 5 years or whatever. What's the reactivity of Chandra? I mean, can it just say, okay, we got to drop everything and observe this along with the other telescopes and get the data down while we can? Is it that reactive?
It is. And in fact, that's one of the strengths of Chandra, is that it is such a powerful observatory that has this capability to be nimble when it needs to be nimble and to get to a source within a matter of days. I mean, that is one of the things that has produced some of the most exciting results from Chandra. Following up the merger of two neutron stars that we detected in their gravitational waves, and it was that follow-up across the electromagnetic spectrum that let us actually understand the event, and Chandra played a crucial role in that. So right now, Chandra is able to point to things quickly when they come up, these unexpected things. We call them targets of opportunity, right? We can't anticipate exactly when or even if it's going to happen, but if it does and we have the opportunity to look at it, we better do it. And so there's mechanisms to do this, but that kind of observation requires a lot of person power to make happen, right? Because planning the mission observation schedule takes a lot of work. It's done weeks in advance based on the proposals that were approved. And it takes a lot of work to make sure that everything is staying healthy, that things are going to be within their limits of operation. And then when something like this target of opportunity happens and you have to suddenly throw out your schedule and come up with something new immediately, that takes a lot of work and that takes people. And that is going to be the first thing that goes away when these budget cuts happen. It's going to be impossible for Chandra to operate that way. And it's a shame because, as you say, these are some of the most exciting things. And in fact, this field of looking at things quickly when they happen, we call it time domain astronomy. That's our jargon for it. But this area was highlighted by the most recent decadal survey of astronomy as one of the most important areas to focus on in this decade. And one of the best tools that we have for it, which is Chandra, and its ability to make these target of opportunity observations, that's going to go away. And it's directly at odds with what the decadal survey recommended we should be focusing on.
Now, give us an overview of the instrument package of Chandra. As I recall, there's 4 different instruments. Tell us what each one does.
Oh, yeah, I'm happy to do that. So there are 2 cameras, right? Let's call them cameras. So there are these 2 cameras. One is called ACIS, the other is called HRI, but they are the things that actually record the X-ray photons after they get focused by the mirrors, and they make the images. So these are like the CCDs or the active sensors in your cell phone camera. They're the little piece of silicon that actually records the photons and makes an image. Now, optionally, and they both have their strengths depending on the science that you want to do, why you might want to use one versus the other. The ACIS camera, the ACIS detector, gives you information about the energy of every single X-ray photon that hits the detector. And so not only can you make an image of the sky and X-rays, but you can also make spectra of every object in that image. This is very different than how astronomy works, say, in the optical. In the optical, you have to choose. Are you going to get an image or are you going to make a spectrum? And if you want to do both, that's 2 different observations. Chandra does it all at once for everything in the field with ACIS. The HRC is a great instrument if the object that you're studying is rapidly variable. It has a really great time resolution. And so some of these things in the X-ray sky, they vary on the order of milliseconds. And so you need something with really great time resolution to catch those kinds of variations. So those are the 2 cameras, the 2 imagers. Now, optionally, Chandra has 2 sets of gratings, and they can be put in or out. And if you're just making images, you leave them out. But if you have a really bright source and you want to get a very high energy resolution spectrum, so you want to know the energy of each photon to really high precision, then you can put in one of these gratings. One is for higher X-ray energies, one is for lower X-ray energies. And they will give you the highest resolution spectrum that you can get currently in X-rays. And that's where all the physics of a lot of these things is in the detailed high resolution spectrum.
Now, what can people do? In other words, what can everybody in the audience do to try to help save Chandra and get Congress to spend the money with a line item?
Yeah, to get that line item in there, the single most effective thing that people can do is to call, to get on the phone. And I know I hate getting on the phone, but I did it, is to get on the phone with their senators and their representative and talk to some staffer in the office. Make sure you talk to a person and tell them to restore funding for Chandra and to make it a line item in the budget. That's what we need. We need to lobby Congress for this. We need individuals to call up and make sure that that message is heard.
And it's important to remember to be nice, be friendly.
Oh, absolutely. This is, yeah, the staffer who's answering the phone in that congressperson's office, they love hearing from their constituents, and the audience needs to understand that they want to hear from you. And you shouldn't be upset with them or upset with things, but just be very matter of fact that this is a tremendous loss to U.S. science. And it's not going to take a lot to actually correct this situation.
Now, this problem, the situation that brought it about, how else does that affect NASA? And that's another thing to say, is that I would hate to be at the top of NASA and having to choose on what side.
Oh, I don't envy that position at all as well, because you're right. There's no good choice about what to cut when you have to cut, but I think that the priorities that we've been told, the reason why it's mainly coming out of Chandra and not any place else, is, they've used language like Chandra is more difficult to operate than it used to be, and it's becoming more expensive, and that is not true. I mean, there are factual inaccuracies in the president's budget request, and if it was based on thinking that these statements were true, then, I mean, that's an easy fix. These things are not true. It's not that Chandra is on its last legs. It's not that it is aging to the point of not being useful anymore. It is still the cutting edge instrument in X-ray astronomy, and it will be for the next decade. And it seems like there is this mindset that Chandra's on its last legs and it's not useful anymore. And that's just wrong. It is continuing to produce world-class science. It's oversubscription. The people who want to use it compared to the people whose proposals get approved remains very high. The number of papers published based on Chandra data continues to grow over time. So this is our flagship. It is functioning wonderfully and should be protected. And the reasoning that we have been given as to why just Chandra, why just the old things, is because NASA wants to make sure to fund the future of astronomy, which I completely agree with. But I think there are compromises that can be made there. The way I've explained it to my students, I'm a professor. I teach 3 classes a semester, and this has been occupying a lot of my time. So I'm trying to relate it to my students or relate it to my friends and family. And what I liken it to is, imagine that you have a child and you have put this child through the best schools, elementary, middle school, high school, the best experiences they could have. You sent them to a phenomenal college. It's not cheap. This stuff costs a lot of money, but you did it. And they are halfway through college, summer after their sophomore year. And you've already prepaid the tuition for the next 2 years. You just need to get them to college. But you find out you're pregnant, and you realize you got to start saving for that baby's college. And what you do is you decide to not take your older student to college because you don't want to pay the gas money to get there. it just doesn't make sense to me. I think you can do both. You can provide for the future as well as continue making it possible for this thing that is producing great results to keep producing great results, because nothing is going to come close for at least a decade.
I want to draw everybody's attention to savechandra.org for more information on this, and there'll be a link in the description below. One of the things that really, Doctor, really strikes me about Chandra is that, one of the banes of the Hubble Space Telescope has been gyroscopes and failing gyroscopes and replacing them and servicing them. Chandra has never been serviced, and they're still working. And there was, as I recall, a minor hiccup with one of the gyroscopes, but it's in reserve. It still works. So this telescope is extraordinarily well engineered and has held up better than even Hubble, to the point that if we're successful and we can get 10 more years out of Chandra, it may outlive Hubble.
Yeah, no, I agree. Chandra is a marvel of design and engineering. Everything on it was made to such an exacting standard because they had that kind of long-term thinking in mind. And you mentioned the gyroscopes, and that's one part of it. Another part of it, I mean, do you remember when Hubble was first launched and it had the aberration? I mean, it still has the aberration, but it was uncorrected, and all the initial Hubble images were so bad.
Oh, yeah.
And they had to get basically put glasses on it on each instrument that goes up. Chandra's mirrors didn't have that problem. Chandra's mirrors, when they made them, they were the most precise mirrors that had ever been made on this planet. They were so smooth that if they were the size of the Earth, the biggest aberration would be like maybe a meter tall. I mean, they were so incredibly well made. And that's what gives Chandra its power. And you're right, it's never been serviced, and yet it still has the capability to go for at least another decade.
Yeah, it's important to remember that those optics are still good.
Yeah.
Everything's still good. Everything's still working.
Everything, is doing great.
Yeah, and I just don't see the logic in it. Again, because it's a cheap fix for Congress.
Yeah. And generally, NASA has bipartisan support. It's this isn't like a political thing or anything. Generally, we understand that these efforts are good. They help our scientific standing in the world. They're the reason that people look up to the United States.
Well, and don't waste something you've already paid for. Get the most out of it, and that's that's apolitical.
Exactly.
Everybody's going to agree with that one. Don't waste it once you pay for it.
Exactly.
And if there's still good science to be done, then that's what they need to do.
Yeah.
So thank you for joining us today, Doctor. And I really wish you great success, and I'll help out as best I can to try to save this telescope, because it's an obvious no-brainer to keep that thing going.
Well, I'm glad you see it that way, and I can't thank you enough for this opportunity. And thank you to all of your audience for listening and helping out. We really appreciate it.
The following is an appeal from Event Horizon. Chandra is a triumph of humanity's pursuit of discovery, a marvel of engineering, and a shepherd of leadership defining national skills from one generation to the next. On March the 11th, NASA proposed a premature cancellation of Chandra's mission due to intense budgetary pressures. The loss of Chandra would be an extinction-level event for X-ray astronomy in the US, a Nobel Prize-winning field that began in the US. But Chandra has nearly a decade of life remaining, and remains the vanguard of US leadership in high-energy astrophysics. It is a critically needed discovery engine in the looming era of time-domain astrophysics. Find out how you can help Event Horizon help Chandra stay operational. Check the link in the description below or visit savechandra.org/act. Thank you.